So now something to remember is the swamp cooler is putting out 100% humidity, right? It's just humid air. It's 106 degrees right now. It's kind of shady. So, you know, it's not the hottest part of the day, but there's going to be a significant cooling difference on this cooler, and I'll show you. So 88 degrees discharge air. So that's a significant temperature difference.
Start this off with some context. Refrigeration rack has a evaporative cooler bolted to the side of it. I've been trying to talk to customers since before the COVID shutdown to let me rebuild the swamp cooler because I was so worried about their refrigeration equipment. It has been over a year. I put in a quote, and of course, they approved the quote a year and some change later. In our first heat wave of the year, it's 110 degrees outside. Yesterday, it was 112 or something like that. We're super swamped, but it's one of those things where I'm so worried about their rack that I dropped everything to get out there because I didn't want this to turn into an emergency walk-in freezer service call, okay? So we're going to start with that, but then I told the customers, hey, I am here. I don't want to have to come back. What else is broken? And they let me know. We had a few things going on. So it was a hot day. We were up there for 8 hours, plus 9 hours that day. Actually, it was today. It's June 16th. We were up there for 9 hours today. I'm beat. I'm exhausted. I look it, I'm sure. I'm tired. But we got them operational. Okay, so watch the video. You'll see a couple different things. It's kind of scatterbrained, but my brain is kind of jelly brain even at this moment. Like just from that heat, working in it all day, I'm just tired, okay? If you guys haven't already, please check out my website, HVACRvideos.com. Shirts. This is my original shirt design right here. This is the Big Picture Diagnoses shirt. There's a couple different colors on this one. We have the flag t-shirt. We have hats. That's the most popular item. Small, medium, large, extra large, flex fit hats. Super awesome. I really like the hats. They're my favorite. They're actually the best seller on the website too. Sweatshirts, beanies, all that good stuff. So please help to support the channel. Check out the website and let's go ahead and get on with the video. This video is brought to you by Sporlan. Quality, integrity, and tradition.
All right, this is a long time coming. It's been over a year and a half, if not longer, since we rebuilt this swamp cooler for this rack. And it's what cools the rack. A lot of people have asked me about an old video that I made about this. Why not just take the panels off and let the units breathe? Well, we're in the Coachella Valley. It's over 120 degrees on the roof. These are all indoor condensing units that are not sized for the high ambient temperatures, okay? So we have to have some kind of supplementary cooling or these units just end up being an issue, okay? So that's why we have them in this rack that blows the air across it. So today we're gonna be rebuilding both of their swamp coolers. We got this one right here, and then we also have this one over here that is their makeup air unit. So we're gonna be redoing both of these, new pads, new pumps, new floats, just going through everything on these guys. So we're gonna be here for most of the day today. So you can see these panels are just a nightmare. They weigh a ton because of how calcified they are. Easiest way to start this process is drop them hard so that way you can break off some of the stuff. That actually helps, obviously being cautious about the roof material and stuff. So it's like a process to even get these doors off because they're so calcified on. So we're pulling the standpipe off and the nut so we can drain it, just letting it drain onto the roof. Then we're gonna clean out the whole bottom of the swamp cooler, clean the blower wheel. We're gonna change the pump, put a new belt on it. This belt was barely even doing anything. It's like we got a temp control. The temp control looks okay, but we'll investigate that too. Yeah, so we're just gonna drain these and we'll do the same process for the other one. We'll clean up the roof around it a little bit, try to clean up the trash too. Want to get these guys operational. Basically, you should be having to rebuild these every season. So, but out here, this one right here runs all year and it's needed. So this one might need to be technically rebuilt 2 times a year. It was way inefficient the way that it was running right now. So you got to get this this little wire thing that holds the pads in out. So what I typically do is walk around and step on it very carefully just to kind of break it free on all edges. Once you do that, then what you do is you lift in the middle. On this particular one, you lift in the middle and it just pops out from over there. So just work your way around. I forgot them. It's always best to bring some super heavy duty trash bags up onto the roof so you can put this media, because when this media dries, it becomes just dust and airborne and it sucks. If you're lucky, you flop the pad over and the whole pad comes out very carefully. This one's kind of doing the same too. Just kind of shake it and the whole pad will come out. And then we'll rinse the things and then get the pads in the trash. We'll put them over here so you can rinse them out. It's not that bad of a process, it's just time consuming. So this is their makeup air unit, and it's in better shape than the other one, but this one has a temperature controller. Well, no, I mean, but this one, no, the temp control set higher, I think, on this one. So it doesn't run as much as the refrigeration rack one. But these pads look like they might have been changed within a year or so. But yeah, they're pretty calcified. So on a water float this calcified, there's no sense in trying to repair it. And on something like this, you are much better off just replacing the water float. It will bite you in the ass later on down the line. So when these things get their seasonal rebuild, always change the floats, because the floats are junk. And then always change the pumps too. They're throwaway parts. These coolers are throwaway coolers, you know? It's just junk. This will be the last season on this one, and then it'll be time to replace the whole cooler. Like, you only get 2-3 years out of them. Cleaned it up as best as possible, put a new standpipe kit on it, new water pump. This motor's a piece of junk. Swamp cooler motors are never great. Belt's a little floppy, but you got to be careful tightening up the belts on these things too tight, because they can't really handle it too much. We're going to plug in the pump once we get it filled up and the water set. I was just testing to make sure the motor worked. I was looking at it. This is actually an emergency motor we had left, so it was a good motor when we replaced the swamp cooler, so we saved it. So we'll throw that back in there temporarily in case this ever fails, because this is a critical item because it's for their rack. So, and we also oiled the bearings. These are those junk seat, like weep bearings that you just, put a little oil and it weeps down into there. All right, when it comes to the pads, what I do is always do a little bit of overlap, about 1 inch overlap on all sides. And if you're smart about it, like this one is the perfect height, so it fits right across that. So always have a little bit of overlap, and you've got to make sure you tuck it under that lip. That's how the water works on this guy. So we're going to tuck it under the lip, and then we'll put the rail down. And we also do our best to make sure these things are rinsed. You drop them a few times, the calcium falls off. So do a good job. It'll make it a lot easier when you go to put the pads in. All right, this one is running. Sounds like the bearings are going bad. We're not going to change that today, but we'll bring it up to them. But yeah, we're good. It's moving water like it should be. We're going to put the other one in. We still got to get a spare belt for it, because we did put a new belt, but I need a spare. So we'll come back with that in a few minutes. So we're making sure that we're oiling the bearings. And again, you put the oil in there and you spin it while it's going, and just keep going. Keep going. And then we already did the other side. That's good. And then we just checked current. We put a new pulley on here. We're allowed to run 10.8 amps, and I think we're running like 10.5. So it says 10.8 right there. So we're good on that. It's pretty aligned, good for a swamp cooler. Now these guys right here, the bearings in these are not that great in my experience. So you never want to like really tighten down on these belts. You don't want them to be super tight, just snug. You should have good even flow. We're good to go. We're gonna put the panels on and start it back up. All right, we're running. We're good. As clean as possible. Water's coming out of every one. It's dripping down. It's gonna take a minute for the pads to get wet. It's important that you don't oversize the pumps too much. You don't want them to be too small either, but this way you can get proper evaporation. You don't want to saturate the pads too much to the point that they can't even ever dry out to get the best cooling effect. So make sure you put the right size pumps in here. For a cooler this size, you want to use no bigger than a 6,000 CFM pump. But yeah, all right, we're gonna put the panel back on. It's really important too that when you're doing these panels, it's the simplest thing, but you've got to make sure that they get installed right, so that way water doesn't drip out. There's nothing worse than a callback on a swamp cooler because someone didn't put a panel on right. It's kind of silly. So you always want to be thorough about that. Make sure the pads are on. Good. We're gonna let this guy soak up and get them wet, and then we'll put all the panels back on. This guy's been running for a little while. It looks good. Not a fan of these pads, but this is all you can get anymore these days. The bearing is going out in this. That wasn't part of our deal this time. We'll bring it up to them. So, but yeah, that's it. Both the swamp coolers are rebuilt, so they should notice that. And then they've got drainage issues up here too. The drains, like there's a drain right here, but obviously this is a giant low spot, and then they have a water leak right here. I'm like, I don't know what to tell you. You know, we tried to sweep it a little bit, but. So now something to remember is the swamp cooler is putting out 100% humidity, right? It's just humid air. It's 106 degrees right now. It's kind of shady. So, you know, it's not the hottest part of the day, but there's gonna be a significant cooling difference on this cooler, and I'll show you. So 88 degrees discharge air. So that's a significant temperature difference, and that's gonna help to cool off the heat from these guys. And then we blow the heat out those little vents. Now those vents, yeah, I'd like to see them a little bit bigger, but they also slow down the air so that way it can absorb more of the heat and push it out. So it does an effective job. So we got a kitchen AC that's not working properly. I think I've done a video on this one before, but anyways, we're starting right here because we just tested control voltage and we didn't have control voltage. And we just tested main power and we didn't have main power. So we're gonna go downstairs and look at the breakers and see what's going on. All right, we came downstairs to the breaker panel and we have a tripped breaker for AC number 5. Now I had shut off the disconnect switch on the roof, so we should be able to turn it off, turn it back on. We're gonna note that that's a 30 amp breaker. That seems really small, so we're gonna see what's on the roof. So if we look at here, we don't have any power exhaust or anything. So minimum circuit is 30.5. maximum 45. So 30 is kind of cutting it close. All right, at this point, we're going to check for voltage and see if we have any shorts to ground. We tested for direct shorts to ground, line and load, nothing. The motors spin, I don't smell anything burnt. Let's check the condenser fan motor. Condenser fan motor spins, so that's a good sign. I mean, nothing's shorted. So at this point, I think we're gonna have to put the panels on and turn it on and see what happens. All right, so this AC has been running for a while we went and got parts. Running at 23, 24 amps. Now, yeah, 24 amps. I'm not seeing anything wrong. I just did a repair on this unit, a refrigeration repair not too long ago. Found, I think it had a refrigerant leak or maybe a plugged up dryer, I don't remember. But I know I changed the dryer, repiped it. But I have told them before on this AC that the electric service coming up to it is not correct, okay? They have got 10 gauge wire and a 30 amp breaker coming up to it. This thing is a minimum 30.5. Minimum ampacity is 30.5, maximum 45. They need to put a bigger breaker on there, and in my opinion, they need to upgrade that electrical service coming up to get rid of that 10 gauge wire. Now, we are in La Quinta, California. It gets well over 110. Max, I think, is 120 degrees. So imagine the temperature of that wire in that conduit. The breakers here also always get full of sand, and they have to replace breakers on a regular. So it's my humble opinion that I'm gonna tell them they need to get the electrician out here. The electrician needs to investigate the electrical service himself, make the decision, but I'm pretty confident he's gonna need to upgrade the service to at least a 40 amp, 45 amp service and put a 45 amp breaker on this thing. That's gonna be their best bet because nothing is checking out wrong. I mean, everything seems to be okay on this guy. So we're discharging good heat. We've got a good temperature differential. We're sweating back to the compressor. Like I said, it's been running for a good 2 hours now. Everything's good. We have a good TD across the coils. It's doing everything it can. So we're done with this one. We're gonna tell them to get the electrician to upgrade the service first. We can further troubleshoot after that. All right, this is another AC that they have down. And while we were here working, we walked over it too really quickly and the evaporator was iced up. So it was part of the coil, not the whole coil. So what I did was I just disconnected Y1 right here, turned it on, let the fan run, and we just let the building air run over it. So we're gonna go through and try to figure out why it was frozen up. We also found that the drain was plugged up, so we blew the drain out, got that all good. So we're gonna need to put service gauges on this one because of the way that it was frozen up, because it was just partial of the coil. There was definitely something there. So we're gonna dig into that right now. Okay, so we just turned it on from it being frozen up, and it's short cycling, and that is not good. It's moving air, I can feel it. It's not in a negative air pressure. My suction pressure is not rising, but this is 410A. We shouldn't have a 1 degree evaporator coil. So we've definitely got a problem. Is it low on gas, or is it a restricted metering device? That we're gonna have to find out. All right, so here's what we're gonna do. I'm gonna rotate that around, and I want you guys to look at my liquid line temperature, 91 degrees, and we're gonna switch it around real quick. On the inlet of the dryer, the liquid line temperature is 109 degrees, and on the outlet is 90 degrees. (96) and dropping. We have a plugged up liquid line filter dryer on this AC. You can actually feel the temperature difference with your hand too. You can tell because we have decent subcooling. Now granted, this is discharge line temperature, but we have decent subcooling, 18 degrees, but we have, well actually that's subcooling. Yeah, that was on the outlet. But then look at on the inlet of the dryer, 27, 31. I mean, it's got really high subcooling, but you can physically feel it on the dryer. You have a plugged up dryer on this guy. From experience, this guy is gonna have an issue in the compressor. Think about it. System's never been worked on. All right. That looks like an OEM dryer to me. It's got paint on it. There's no reason. I've maintained these units. They're relatively clean all the time. I mean, there was, you know, that year of COVID, they didn't do maintenances, but I mean, they weren't horrible. But why would the dryer plug up? Moisture in the system, okay. Or contaminated compressor oil. And it's 120 degrees in the summer out here. This unit's 9, 10 years old. The oil in the compressor is damaged from running in this heat for so many years that you know, there's not a whole lot it can do with from overheating. I mean, you know, right now, currently, outdoors is 106 degrees right now. We have 115 degree condensing temperature. It's hotter inside that compressor. Let's look at my discharge line. My discharge line temp is 227 degrees right now. Okay, that's borderline beyond what Copeland recommends for a discharge temp. Now, granted, we have the panel off at the moment, but this system is just overworked and it's dead. So here's the thing. You know, we'll talk to the customer. We'll tell them, you know, my quote for me to put on this thing would be to change the compressor, change the dryer, new refrigerant, clean the system, but I can't guarantee that we're not going to have a plugged up metering device. I can't guarantee that we're not going to continue to have problems because there could be contaminated oil all throughout the system. I could do my best to try to blow it out and stuff, but their best bet would be honestly to change this unit with the life of it. It's done, it's beat up. But you know, we'll bring it up to the customer and let them make those decisions on how they want to do. But I'll leave it running, but I mean, you know, it's inevitably going to end up in a grounded compressor with a 16 degree evaporator. It's just going to take a dump. But we're going to go ahead and shut it off, take all my stuff off, and give the customer a big picture quote and see where they want to go. If you look in here, look at the metering devices, they're already starting to frost up too. But again, you know, I don't want to just sell the customer a new unit. I would gladly put a compressor in it, but I'm under the impression that the oil, if I pour that oil out, it's going to be black. And it's because the system's been overheating for too long. And what are the odds that's not in the rest of the system too? Plugging up everything. There's probably dirty oil in the, I mean, eventually I'm surprised it hasn't grounded out yet. It's probably, you know, destined to ground out within the next couple weeks, especially running like this, you know, barely doing anything.
All right. It was another one thing turns into another, right? So again, I did it to myself, but I had told the customer, look, it's hot. I'm here. What's broken? I don't want to have to come back. So I busted my butt. You know, it was a hot day. I had someone else. I had an apprentice with me working. He's doing really good, by the way. But we got the swamp coolers, plural, both of them rebuilt, cleaned up, operational. We put them back together, and then we jumped into the ACs. Okay, the swamp coolers really aren't that hard. You know, like I said, they're seasonal throwaway swamp coolers. So every couple years you throw them away, you start over. They don't build these things. They're not made to last. Okay, especially on the small one, it has a hollow shaft. Those stupid wheat bearings, they're junk. Okay. The motors are junk. They're just trash. You can't buy a quality swamp cooler these days, at least not at my wholesalers. If you guys have something better, let me know. But also within reason. The customers, they don't want to spend $1 million on these things, you know. It seems that the old ones, evaporative swamp coolers, whatever you want to call them, they used to last a lot longer. But on a side note, the term swamp cooler, okay, I know I'm going to get a million questions about that. Why do they call it a swamp cooler? Well, in the video, I said it's 100% humidity. It's pure humidity blowing out into the air. So it makes it cool and swampy, like sticky, humid, nasty, okay? Swamp coolers are really only effective as a cooling medium in very, very dry climates. Even here in Southern California, they're not the most effective thing. And some of it, like in our high desert region, where I was out in the Coachella Valley, they really aren't that effective because it does get a little bit humid out there. Ironically, on a side note, it gets humid because of all the golf courses and swimming pools because it's a naturally dry desert. That's interesting to think. There's so much grass, so many golf courses, and so many swimming pools that it actually makes the climate more humid. That's a trip, right? Anyways, back to the video. So the swamp cooler is effective, especially on that rack. It does a good job of, as a pre-cooler, right, cooling all the condensing units. But there's some things about them, okay? They're not difficult to work on per se, but they're tedious and you have to do things right. And like I said, there's nothing worse than a callback because you decided not to change a $20 water float, you know, and then it turns into just a pain in the butt service call, especially for this location. It's an hour and a half away from my shop. You know, nobody wants that. So you do have to make sure you take your time. It's really easy when you work on these things because they look so dumb and so simple. You tend to like, it's no big deal, you know, skip steps, but then it turns around to bite you in the butt. So you always want to take your time, do it right, clean them up, treat it like it's your own, you know, and don't be afraid, in my opinion, to replace parts. Okay, those water floats, they're throwaway floats. The pumps, they're throwaway pumps. At a minimum, I get a float and a pump every single time I rebuild a swamp cooler, and pads, of course. Sometimes they get a new motor, sometimes they get a new temperature controller. In this situation, they were okay, and I had a spare motor in there, so it'll be okay, you know. But, you know, we just try to be as thorough as possible. All right. Now, when it comes to the ACs, that's another thing. So the first one I went to, I told and said in the video, I already had a hunch that it was an electrical service issue, but I still looked at everything, still went through the unit. I did not put my service gauges on it. I don't always put my service gauges on stuff, okay? I had just done a repair. I made some educated guesses by looking at the system, the way that it was performing, the metering device, the condensation coming back, you know, the evaporator temperature differential across. I didn't think I saw anything wrong with that. Okay, so I was leaning towards an electrical issue. So, you know, I found a tripped breaker. Of course, before I reset the breaker, I turned off the disconnect unit on the roof. Okay, so that way I could turn it on, go up, and troubleshoot before something happened, you know, if there was a problem. And then I just systematically went through all the checklist items that I know of, okay? From experience, I spun the fan motors, right? Real easy. Look for any electrical shorts. Test, you know, the circuits to ground. Make sure there's no direct shorts to ground. Everything checked out okay. So then I reset it. And what you guys didn't know, I think I mentioned it, but is that from the point that I reset it and the unit started up, we went to lunch. We went to this couple different supply houses to pick up belts and a pulley and different things. So we were gone for a good hour and a half, almost maybe 2 hours. And that unit ran in the hottest part of the day for about 2 hours straight. No issues. We came back. We worked on another AC that you guys saw too. The AC was still running fine. So at that point, I'm not comfortable with the size of that circuit breaker being at 30 amps when they're calling for a 30.5 service, okay, or circuit breaker. I know that 0.5, that's not that big of a deal, but out here where it gets so hot, and also I know that they go through circuit breakers quite often because they get full of sand. And I mean, literally, I'll go over there and I'll pull a circuit breaker out and just tap it, and the sand will just come out of the circuit breaker. So they have a lot of issues with that, but I'm not super comfortable with that 10 gauge wire either. It's marginal, you know, for a 30 amp, you know, but I'm not comfortable with it. So, but I'm not an electrician, and I leave that up to the electrician. Let them know. Now, I suggest we go up to a 45 amp breaker, which I think was the maximum. Go ahead and upgrade that to a minimum 8 gauge wire. And I think they would be okay. You know, 45 amps, you're pushing, you know, 50 amps. I like to see 6 gauge wire, but that's a whole nother conversation. I don't want to get into arguments with people about that, you know. But that's a whole thing, right? But I'm not an electrician, okay? So I leave that up to the electricians, just give them my advice. We'll see what happens with that kitchen AC, with the kitchen AC, okay? And then I jumped on the dining room AC. The dining room AC is the one that was short cycling, and it was frozen up in a weird way. Now, using my senses, I walked up to the unit originally. I just ran over there real quick while we were working on the swamp coolers. Ran over there, and I could see frost on the compressor, suction line going back. Opened up the evaporator, and it had a funky ice pattern. And I wish I would have gotten it on film, but I didn't. But it had a funky ice pattern where there was a solid chunk of ice, but just in the middle of the evaporator, not on the top, not on the bottom, okay? Dead giveaway, we got a refrigeration issue. There's something wrong here while it's running if it's iced up like that, okay? So I already knew I had to put my service gauges on it, but I had to get it defrosted, okay? So went ahead and disconnected the compressor terminal, got the unit with the indoor blower motor running, defrosted the ice, and went through it, and you guys saw what I found, okay? We had a plugged up filter dryer, liquid line filter dryer. Now, the purpose of the liquid line filter dryer is to clean the refrigerant, to try to catch any contaminants before they make it to the metering device, before, you know, it's there to catch problems, right? It's there to clean up moisture and different things, but we have not worked on this system ever, to my recollection. I went through my notes, too. I don't see anything. And the dryer had it looked like factory paint on it. If we did work on this, it was very back in the, you know, when we installed it, like in 2009 or something like that. But, you know, anyways, I don't think that there's anything that could have caused that dryer to plug up. Now, if it's something that we've done repairs on, hey, maybe someone didn't pull an evacuation right. Maybe they didn't, you know, whatever. But no, this has not been worked on. So you got to think the ambient temperatures that this thing runs in, how hard of a life it has running in those hot. So basically where it is from May until the beginning of October, it's over 100 degrees all the time, even at nighttime. Right now, it's 8:15 at night, right? June 16th. I just got home from all this, sat down and ate dinner, and now I'm here editing a video. But it's still 95 degrees out there. And that equipment's still running. It runs all the time. Every AC was running all day and never shut off because of the heat infiltration of that building. So that equipment is beat down. Now, I actually already changed one of their ACs, because I changed all of these ACs back in 2009, every single unit on that roof. And I've already changed one of them because of same issues, just constant compressor issues and stuff like that, because they just run really hard, okay? So just because of my experience and, you know, my, you know, just opinion on the matter, I am going to recommend to the customer that at a minimum we change the compressor, the liquid line filter dryer, all the refrigerant. I try to clear the metering device. We may be plugged up, we may not, and try to blow out the condenser. But I don't recommend that, because they're going to be well into the thousands of dollars. And it's like, man, you could slap a new unit up there if we can get one. That's a whole nother problem. But if we can get one, you could slap a new unit up there and have a new unit, you know, and probably not have issues for a while, okay? On a side note, though, I do want to find out, because I'm not a super fan of all this new technology coming out of these new package units, and I don't know if I want that new axial eco blue fan motor thing. So hopefully I can find a unit without that, with just a standard blower assembly. But that's a whole nother conversation for another day. But anyways, you guys have heard enough of my ranting and my rambling. This was a very scattered video, but this is you know, normally my videos are like one thing. This is how my days go all the time. It's chaos like this. It's boom, 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 knocking it out, you know? People ask, why do you spend so much time on one call? Well, you guys don't know that I'm doing multiple things on one call, and I'm super thorough too. So it was a long day. I'm exhausted. I'm done talking. I'm going to wrap this up. Thank you guys so very much for watching and making it to the end. Please, like I said in the beginning, if you haven't already, go to my website, hvacrvideos.com. You can support the channel if you see something you want. If not, check out truetech.tools.com. Got tools on there. You can use my offer code BIGPICTURE, one word. Get a good discount on your order. I get a small commission from that. Helps to support the channel. You can also support the channel via Patreon, YouTube channel memberships, PayPal. Just go to the show notes of this video. There's information for everything, okay? Thank you, thank you, thank you. I appreciate you all, and we will catch you on the next one, okay?